I'm Johannes Emmerling from CMCC. And in this next 10 minutes, I focus a bit connecting to what Robert presented, but also with some different works that we did on the dimension of, or the more economic dimension of pathways in terms of especially equity, both within countries, within the EU, but also globally, and also other, let's say, economic metrics of the transition, and on a few of these highlights. Let me start by the issue that also Robert raised of equity, like how much is the European reduction, let's say, considered from a fairness perspective at the world level. Now, there are these well-known, let's say, principles of burden sharing that you can see here. And in this work that has been led by PBL, we focus on 3 of them. So we have kind of an conversions per equal per capita emission equity principles, one based more on historical responsibility, and one more on GDP, or the ability to pay. So in here, just a highlight of this tool, which is also an online tool available. We focus on 2030 and the 2040 targets that Robert also just showed. How much the current policy discussed targets are within the range of equity-based, fairness-based principles of reduction. So here on the right, let's focus just on the European Union. You see that for the 3 bars, which are 3 different principles. So the first one is based on responsibility, so cumulative historical emissions. Then you have the capability based on, let's say, economic capability to reduce emissions, and equality, which is basically per capita convergence. And you see that the European 2030 target of 55%, so here I converted to reductions with respect to 1990, of 55% is in the range, but a bit on the lower end of what would be fair, especially if you take into account responsibility. Then the optimal reduction, or reduction plus transfer effort by the Commission, by European Union, would be around 130% reduction. So much more, of course, because of the emissions and have been high in the European Union. For other principles, you're getting a bit closer to the 55% target. So as Robert said, there is a bit more, let's say, more ambition could be warranted, or it could be also transferred. So you can see here that also, of course, some of this part could be paid to other countries, something discussed a lot at the last COP also. But roughly, let's say, I think the starting point is reasonable, but especially taking into account historical responsibility, could warrant higher reduction. If you look at 2040, and here comparing it to the 90% reduction target, it's now mostly discussed, even though there's discussion. You can see that here also fair targets would be a bit higher, but the difference is slower because, of course, over time, responsibility increases in other countries. So here we see a smaller range, 70 to 100%. And so there actually the 90% target is on an equity or fairness principle seems reasonable. Maybe lower ones would be less equitable from this perspective. But this is something you can check it out. There's this website, carbonbudgetexplorer.eu, that will soon have also the paper attached to it. And I think it shows also that we need to see the EU effort within the global responsibility and sharing of the effort across countries. Okay, now let's move on to the implications within the European Union. And I wanted to show one figure, an additional figure, and this also links well to Georg's point on model differences, which I think is important. And it's the carbon price, because we saw, of course, the emissions, which are very tightly defined by the different targets of 2030, 2050. In terms of economics and costs, there are some significant difference among others. Here, I just show the current version of carbon prices. So these are the carbon prices required to get to net 50, to net zero by 2050. And there you see an important difference, right? From slightly above 100 to up to 1,500 euros per ton of CO2 in Europe. So this is across all greenhouse gases, kind of an ETS2 type of price, but it's usually all mitigation. And this, of course, has very important implications. And there, I think this uncertainty is also that this from all, let's say, economic studies or other, let's say, econometric works, that this uncertainty is not something that can be reduced, right? We don't know, especially given that it's a marginal price, what price would be required to lead to this, the pathways that Robert just showed. And this, I think, also important to take into account. So to me, that's more like a feature than a bug, that this is really like a key uncertainty, and because we did not harmonize all these cost assumptions, etc. So that really depends on many features and many aspects in the whole model. That's, I think, important to take into account, which will have important repercussions on fiscal balances, on ETS revenues, and also GDP impacts eventually. And this is something we are also at the moment diving a bit further in. We'll be finalizing it in the papers to come out hopefully soon. One of the repercussions that we looked a bit more closely into were related to distributional implications, right? So how does carbon pricing or in general, let's say mitigation in Europe, but also globally affect households? Because that's of course very important. So here there's a study on Greece, but we had some other studies also in Eastern Europe, how this kind of a net zero type scenario affects household across deciles. So here we have the 10 deciles from the poorest to the richest. And here for Greece, we find, well, because of course, direct energy expenditures, plus then here also take into account expenditures like EDV cars and heating systems are highly regressive, so have much higher burden for poor households, which has huge implications for the distribution incidence, right? Which households are affected if these policies, especially these high carbon prices, are enacted. And this is not only the case for energy prices and carbon prices, which basically affect energy costs, but also for subsidies. So in another study where we focus on solar PV, which we have seen is of course one important technology, and here a case study on household data for Germany. We look at a scenario that is kind of also in line with the current policies and expected, let's say, subsidy schedule that has been discussed. And we look at micro household simulated adoption of solar PV. So this is only residential solar PV, which we have seen, of course, over the last since 2008, has seen this huge uptake until this was 2023 to up to 20% of households in richer deciles. Here again, you see household deciles. Also by urban and rural, there's a divide, but especially you see a divide by income deciles, so the decile 1 to 10. Of course, that there's much higher uptake in richer households. And if we look at 2040 projected, we basically see this to increase. I mean, there's a huge uptake of up to, on average, I think, 50 to 60% of households, but with a huge, let's say, this distributional incidence, especially, of course, the poorest 20% due to liquidity constraints and also different housing types will benefit very little. And here the size of the bubble is basically how much feed-in tariffs are paid. So we see a huge regressive incidence of subsidies going much higher to richer households. Also, this kind of potentially leading to, of course, distributional implications that should be taken into account when looking at the economic, but also let's say the political feasibility and acceptability of these policies. Now, a last point I want to make on this issue of distribution is from a global study. So here we looked at one country in the EU, France, but then also other 9 countries globally, including China, US, India, big countries. And I want to focus a bit here first on the cost of inaction, right? Because so far we never looked at climate impact. So what does happen if there are climate impacts? And here we added this climate impacts to the picture, especially to distribution incidence. So let me see. So what would happen under kind of current policy scenario? This is basically policies until 2020, and then continued. We see inequality, and this is the Gini here. So you have inequality, and these are basically all the different models and all 10 different countries. We see an increase in inequality in virtually all countries, on average about 1.4% on the Gini, due to climate impacts in the current policy scenarios, right? So when there's no mitigation beyond the current existing policies, basically leading to distributional, to regressive climate impacts. But now if you focus on the 1.5 degree scenario, on the other hand, and on 2030, basically in the nearest term, we see a small increase, but it's relatively small on average, around 0.1%, 0.1 points, which is significant, but not so large compared to the impacts. Meaning that, well, the policy, of course, leads to an increase, but compared to the impacts, it's by, let's say, one order of magnitude lower. So also important to take into account when discussing these potential regressive impacts of policies, that potential impacts could be much larger in terms of incidence, even though they will realize, of course, typically only by 2050 or the end of the century, much later in the picture. And finally, and this is the last point that I want to make, is the question of redistribution or revenue recycling. And in this study, we introduced a kind of climate dividend, as it has been discussed in Austria and Germany, in several countries, basically redistributing the carbon revenues from a carbon tax or an emission trading scheme. And here we see that basically this can have a huge positive impact, in the sense reducing the Gini in the short term, of course, by up to, on average here we see 2.4%. Of course, here there's a large uncertainty. Poorer countries have typically a bigger impact, which is evaporating a bit over time because carbon revenues dry up. We get to net zero, of course, then revenues go also to zero by definition. But basically meaning that in the short term, it can really, by way, overcome this kind of a regressive impact on mitigation on inequality. And this is also a related study that was done with the CGE model, similar, again, looking at what to do with the carbon revenues. I mean, this has been discussed now in ETS. It's also not been discussed now with ETS2. And this study was basically looking at two different types, a climate dividend, like I just showed before, or also a reduction in labor taxes. So instead of giving the money back to people, we could reduce labor taxes to make them less distortive, and of course increase potential employment. And here we see the impact on potential employment in Europe, which can go up to 1.5 million additional jobs. Of course, you have some losses in fossil fuel industries aggregated when you have this kind of revenue recycling through the labor tax reduction. It shows another way of redistributing with potential great benefits for the economy. Okay, so that's basically the main points I wanted to make. So there's kind of a target gaps in terms of equity, but then also there's this whole issue of distribution on the side of carbon pricing, but also on subsidies. However, if you take into account the cost of inaction, this looks much less grim than without it. And finally, the climate dividend, or let's say reducing other taxes, can more than overcompensate the costs in the near term.